I'm going to go over the treadmill motor conversion I did on my 12-inch Atlas Craftsman lathe. Kind of how it works and what I had to do to make it all work. The reason I originally thought about converting this thing to a treadmill motor is I was making this thread adapter for the spindle threads, and I was running into this. I had it chucked in this tiny little chuck here, and it was basically like tapping into a blind hole, and I crashed the cutter. All because with that coarse 8 TPI, the carriage moves so fast, and I wanted to slow that down a bit. So I'm just going to kind of show you how it works here. Turn the switch on, obviously. Hear the cooling fan take off. That runs the entire time the lathe is powered up. Still have the original drum switch that came on this lathe. I remounted it down here. It used to be mounted up on top of the cover there, which was kind of inconvenient. But, yeah, we'll crank her up here for you and let you see how it works. Got a potentiometer here to control the motor speed. Digital tachometer, just a cheap one off eBay. It does have a soft start, and it does ramp down when you shut it off, so if you do run into trouble, like your part comes loose in the chuck or you crash it, whatever, it's not just going to shut right down, unless you grab the drum switch and put it in neutral. With this massive chuck on this little lathe, it has quite a bit of inertia and takes some time to slow down. One other neat feature here, if we leave this on, and we'll shut it off. Say you got done with whatever you were machining and came back the next day, chucked something in there and flipped her on, it's not going to take off because it's safety built into treadmill motor control. If we reset the dial back to 0 and then come up on it, then it'll take off. Nice little safety feature. Still got reverse here. If you're machining something and you hit your speed you want, you can leave the potentiometer there at the same spot, and it'll resume whatever speed you had selected. I got it in back gear now. See, we got her spinning at 4 RPM. It still has a ton of torque going this slow too, which is unbelievable. But if we look at the chart here, we're in belt position 1. The slowest that this lathe would spin in its original configuration was 28 RPMs. Let's just show you what that looks like here. Pretty close there. There we go. Disengage the back gear, put it back into direct drive, and I'm still in belt position 1. So belt position A on the motor be 164 RPM, and B, she's a little scratched up here, but that's 500 on the B motor position. I'm going to show you what it does when you crank her wide open here. So that gives us about 500 RPMs. To do that, I'm going to show you, we'll take a look in the cabinet here. The lower cabinet here, I'll show you the inner workings. Here we got a garden variety treadmill motor here. They're pretty much all the same. I've built a bunch of contraptions with these treadmill motors and they pretty much all run the same thing. The control board in there, everyone I've taken apart has had the exact same control board in it. So it kind of makes it handy once you get to know how to use them. But anyways, you can see on this motor, if you can read upside down, it's rated for 2.5 horsepower at 6,700 RPMs. 1.5 horse continuous duty. I checked this. I'm sure maybe that controller puts a little bit more power out than what that rating is, but I think I had 7,600 RPMs total. I can't remember for sure, but I had to size that pulley accordingly so I wouldn't overspeed this machine. And there's a cabinet cooling fan. That's I stole that out of a microwave that died. That pulls cool air in, sends her out through the door here, and keeps everything cool. I didn't modify anything on the cabinet itself. I used the bolts that originally mounted the motor. Get the old motor down there. This motor is about half the size. If you guys are using treadmill motors and you want a reversing function, see I grabbed the motor leads here and that goes into my drum switch. Also, when reversing a treadmill motor, this pulley is threaded on. So there's a, can't really see it, but there's a little bit of tack weld on the end of the shaft to keep that from unscrewing off of there. Better look at this pulley I had made on this lathe before ripping it all apart. We'll pop the belt off here. See the profile of the grooves. Didn't turn out too bad. This is probably the most intricate thing I've ever machined. I'm just a novice. I'm no professional. See the motor shaft pulley there. This is the original driven pulley off the treadmill. And this is the original belt. I don't know why they put such a narrow belt on there but still have the grooves in the pulley, but whatever. I ordered this belt on eBay. I think it was 10 bucks. So I figured out the length I needed. Also, if we got this motor wide open, it won't ever spin any faster than the old motor did in belt position B. I figured I better not exceed that because of the bearings and whatnot. They weren't designed to spin that fast, so I figured I'd keep it safe, and it makes it easier for if you're doing belt changes and you can still refer to the chart, whatnot. Here's a bunch of pictures I took when I made the pulley. I cast the aluminum myself in my furnace. You could about imagine what a 9-inch aluminum round, 1.25 thick would cost. So this nice shiny new pile of aluminum used to be a Allison 1000 transmission bell housing and a couple old snowmobile pistons and cylinders. And laying there you can see the cake pan I had bought to cast aluminum into. I didn't have any way to hold something this big in my lathe. I didn't have a chuck that big or anything like that. So I laid my faceplate on there, traced it out, got it centered up the best I could. I drilled and tapped it for 3/8 course bolts and bolted it up. And to my surprise, the rough casting was within 10th thou runout. So that was nice. Here's the boring of the hole for the shaft, the belt profile, and drilling a hole for the set screw. The control box is mounted on a little swinging bracket here. You can swing it out of the way so I can get the top cover open. The power switch on here is a 15 amp breaker. I stole that out of a power strip. The tachometer is off of eBay. I think 15 bucks I paid for that. And 3 of these 5K potentiometers on eBay as well I bought for $5 shipped, I think. I mounted the Hall effect sensor. I just drilled a hole in the cover, stuck her back there, it's out of the way. And that reads off that magnet stuck on the spindle shaft. Spin her up here. See the light blinking as it reads. So the way this thing's wired up, power comes into the switch, you flip that switch on, it sends power to the motor controller and the cooling fan that runs steady. When the switch is on, the cooling fan runs. But also I got 120 running to one of these here wall warts. See this one, everybody's got these stupid little things laying around. 12 volt 1 amp output, because the tach needs 12 volts to run. Hopefully I went over all that well enough to understand, and I suggest doing this conversion. Made it a lot more user friendly, and just the extra horsepower really helps. If you got any questions or comments, I'd love to hear them, and thanks for watching.